In this problem, we need to write down the nth term of the sequence a sub n that is suggested by the pattern. And for these problems, we really don't have a set number of steps that we're going to go through to get our answer. This is a little bit more creative in terms of we're going to have to look and see for each problem what does it look like the pattern is. So this is inductive reasoning as opposed to deductive reasoning. So when we look for a pattern, we call that inductive reasoning. Now, what I'm going to do to try to come up with a formula for the nth term is I'm going to make a table. And I have 4 terms. So I have n, and I have a first term, a second term, a third term, and a fourth term. So when n is 1, then our first term is 4. So this is a sub 1, this is a sub 2, this is a sub 3, and this is a sub 4. And of course the pattern continues, and the question is, what is the formula to give me a sub n? All right, so when n is 1, then a sub n is 4, a sub 2 is negative 8, a sub 3 is 12, and a sub 4 is a negative, oops, let's do that again, negative 16. All right. So now what I want to do is try to figure out, well, what exactly is the pattern to these numbers? And the first thing that I notice, and this is something that really stands out here and that happens in a lot of problems, so you kind of want to have this technique in your pocket to use. I notice that the signs are alternating. So 4 I could write as 1 times 4, and then negative 8 I could say, well, that's negative 1 times 8. 12 is 1 times 12, and negative 16 is negative 1 times 16. So when we see this pattern of 1, negative 1, 1, negative 1, or negative 1, 1, negative 1, 1, it doesn't matter what the order is. But when the sign is alternating between negative and positive, then what we're going to do for our nth term is we want to say that this is going to equal a negative 1 to a power. Now it might be negative 1 to the n, or it might be negative 1 to the n plus 1 power. So how do I decide between those two? It depends on whether you start with positive and then go negative, or if you start with negative and then go positive. So we're going to look to see, well, if n is an odd number. So here we have n is an odd number, and when n is odd, then our sign is positive. So if I put an odd number in for n here, I would get a negative result, right? Because if n were equal to 1, then I have negative 1 to the 1 power, and that gives me negative 1. So that's no good. I don't want that one. So I want this one, because if I let n equal 1, then we have negative 1 to the 2 power, negative 1 squared is positive 1, so that works. And then it's always going to work alternating, because always one of these two will work. So let's write that down then. So I've got negative 1 to the n plus 1 power. And of course there's more to this problem than that. So I've worked out what the sign should be. So now I have 1 times 4, negative 1 times 8, 1 times 12, negative 1 times 16. And what I notice is 4, 8, 12, and 16 are all multiples of 4. So I can rewrite this as 1 times 4. Negative 1 times 8 is negative 1. times 2 times 4. 1 times 12 is 1 times 3 times 4. And negative 1 times 16 is negative 1 times 4 times 4. So what is the pattern here? Then I can see that I have 1 times 4, 2 times 4, 3 times 4, 4 times 4, where we have the value of n times 4. So that would be multiplied by 4n. And that is our formula. So that's how I came up with my answer. It's not the only way to come up with the correct answer, but it's the easiest way for me to see it. And I don't think the calculator is particularly helpful in these types of problems. So I would really just make the table. I think the table is really the key to figuring out what your answer is. And that's how you do that.